I want to give some examples of using random integers in Matlab to estimate probabilities and also to estimate expected values. So, for example, let's estimate the probability that if I roll 3 dice, one of them is a 5. So let's do this in a function. And let's call it dice underscore prob for dice probability. I'm going to have input n, and output is going to be p, which will stand for probability. And what I want this to be is that n is the number of experiments we do. So remember, in another math class, you might try to find the probability exactly, but that's not how we're going to do it in this class. In this class, we're going to try to find estimates for the probability. And what's p? P is going to be the probability that if I roll 3 6-sided dice, we get a 5. So that's what I want to do. So a single experiment is going to be roll 3 6-sided dice and look at it, and it'll be success if I see a 5, it'll be failure if I don't see a 5. So that's a good sign that we're going to use a for loop. So for I equals 1 to n. So each iteration through this for loop is going to be one of our experiments. And what's an experiment? Rolling 3 6-sided dice. So let me call it, how about x for experiment? And now remember how to use rand_i to simulate this. So I want it to simulate rolling 3 6-sided dice. So first I'm going to give it a 6. That's saying the outcome is 1, 2, 3, 4, 5, 6. And then I want to roll 3 of them. So I don't really need the brackets, but for me it's easier to read if I have the brackets here. So it's numbers 1 to 6, and then I'm going to get a vector of 3 of them, a row vector of 3 of them. And now I want to know, did I have a success or not? So let's test that. So I'm going to do it in as succinct a way as I can. If any x equals 5. So remember, x equals 5, that's going to be a 1 by 3 matrix of zeros and ones. 0 every time it's not equal to 5, 1 every time it is equal to 5. And this any is asking, is at least one of them equal to 5? So if any of these is equal to 5, then that counts as a success. So let's go up here and let's say success. How many successes have we had? Now it's 0. And if I get a 5 in this specific experiment, then I do s equals s plus 1. And then what's the outcome going to be? It's going to be the probability, which is number of successes divided by number of experiments, which in this case is n. So let me save it. There's the dice probability. So remember, probabilities are always numbers between 0 and 1. 0 if it never happens, 1 if it always happens, 0.5 if it's 50-50 whether it happens or not. And so maybe naively you'd expect that the probability of this is 50-50, because there are 6 possible options. Each one has a 1 in 6 probability of being a 5, so you might think add up 3 of those and you get 1/2. So let's test this out and see if it's true. So let's go here. Let's do dice probability of, how about 4? So let's run 4 experiments. 0. Okay, well, I actually kind of like that because we know 0 is not the correct probability. Let's try, instead of 4, let's try 10. Okay, there's 0.4. Okay, let's try a bigger number, 1,000. Let's try a bigger number. Let me start moving to exponential notation. 10,000, 100,000, and sometimes in the homework I'll say keep trying bigger and bigger numbers of experiments until you get the same answer to 2 decimal digits. So in this case I got the same answer to 2 decimal digits, so my guess would be that 0.42, also if I'd gotten 0.4199, I'd also count that as being the same. So that's my guess. Let's go up to 10 million experiments and see what it gets. And we can tell this is around the limit of what Matlab can do comfortably while I wait for it. So this is like doing 30 million total experiments, or 30 million total dice rolls. Okay, so again, to 2 decimal digits, it's 0.42. So that's probably a good estimate. Let me do one more computation in Matlab. This one, instead of being a probability estimate, it's going to be an expected value estimate. So let me make a new function. Let me call it dice_exp for expected value. And it's going to be very similar. N is going to be the number of experiments. And now the expected value, let's call it E for expected value. And what's the experiment going to be? It's going to be roll 3 dice, just like before, and compute the biggest of the rolls. Okay, and I want to know what's the expected value of that experiment. So that's like saying, what's the average biggest value from 3 dice rolls? So if I just rolled it once, then I know, me personally, I know that the expected value is 3.5. So if I roll it 3 times and take the biggest one, I expect the expected value to be bigger than 3.5. Because for 1, it's 3.5, and the more rolls, if I'm taking the maximum, the bigger the expected value should be. So I'm going to use a for loop again, for I equals 1 up to n. And again, let me call it x for experiment. This will be rand I 6, and I want to do it 3 times. So this is how I do it, just like before. And now what do I want? I want the maximum value. So let me call it m. This is going to be the maximum value of x. And let me do t for the total. So I'm going to add up all the maximum values. So t equals t plus m. And then at the very end, I'm going to do the output, e. Up here we see it's the output. This is going to be the total divided by the number of experiments. So I saved it. Now let's try it. Dice expected value. And remember, I expect something between 3.5 and 6. Okay, there we go.